Hello class, welcome to our lesson today dealing with section 5.6. This deals with a topic called direct variation. Before we get started on this topic, this often is a topic that confuses a lot of students, so you want to make sure you take some good notes today about direct variation. Your homework questions should correlate to the questions from our video more so than maybe any other lesson, because I know how challenging this topic can be for a lot of students. The first thing we're going to look at here is what direct variation is and what it represents. So direct variation is in the form y equals kx. So k is a constant. It's called the constant of proportionality. If you want to impress someone about what you learned today, you could tell them you learned about the constant of proportionality. Now the k value is kind of like a slope. So they use the letter k because there's different versions of variation that you will learn throughout all of your different math classes. So that's why k is used and maybe not m for slope. What you'll notice here is that this graph goes through the origin, okay, and has a linear kind of aspect to it, which means direct variation, two quantities that show direct variation are also proportional. Okay, that also means you can find the unit rate as well. So really what we're trying to do is just figure out what the slope is. So notice from 0, 0, I go up 2 over 1, and that's where the 2 could come from as the constant number. Okay, so every equation for direct variation should be y equals a number times x, and our goal is to typically find the number that's used in order to figure out what the equation for the direct variation is. If we're trying to show if two things show direct variation, all we really need to do is show if they're proportional or not. So for this first one, this one's not proportional. It's not going to go through the origin. You could do that graphically by graphing the ordered pair. Remember, x is left and right and y is up and down. Or just set up the fractions. 1 over negative 2 is not the same as 2 over 0, etc. 3 over 2, and those don't match up. The second one is proportional. Now don't say it's no because 0 over 0 doesn't equal 2 over 2, because 0 over 0 is not a situation where you can really use that to help find your answer, because that's what's known as indeterminate form. But does it go through the origin? Yes. And does it have a nice linear progression? The answer is yes. So when you're looking at these scenarios, you want to make sure, does it go through the origin and does it make a nice line kind of going in the upward direction? That'll make for a good direct variation answer. The next thing will be from an equation, does it have direct variation? So direct variation was always in the form y equals kx. So what you'll notice is there's a y on one side, x on the other, and a constant that's being multiplied by the x. The first one is no because there's a plus 1. That plus 1 moves me off the origin, so 0, 0 is not part of the graph. Anything with adding or subtracting a number is probably going to be no. The only time it would be yes is if it was plus 1 on both sides and they could cancel out. The second one has x and y on each side, so that's a good sign. And if I try to get y by itself, you have to think of it like solving an equation. So to get rid of 1/2, I multiply by its reciprocal, which is 2. And then y equals 2x would be the direct variation equation. Notice it's y equals a number times x, and that would make the answer yes. That also would make the constant of proportionality 2 in this case for part B of this question. Okay, so just going over a few things to show direct variation. The first one's no, it doesn't go through the origin, it goes through 0, negative 2. Second one is yes, all of these fractions will match up, and if you graph it, it makes a nice line, and it will go through the point 0, 0. Don't say the answer is no because 0, 0 is not written though. The last one is going to be no. And, again, don't assume it's yes or no just based on 1 point. So just because it goes through the origin doesn't make it yes, because if you use the x and y values, x being negative 1, y equaling 2, negative 1 over 2 is not the same as 1 over 2. And so this graph actually makes what looks like a V. That's actually an absolute value graph, or a version of it. But this graph would not show direct variation. The next one, if you try to get y by itself, and I know this is kind of a difficult concept at times, but essentially x and y have to be on their own sides. So since x and y are on the same side, when you solve for y, it's 3 divided by x, and that's not direct variation. That's a different version of variation that you'll learn later on in your algebra classes, but it's not direct variation. The next one is yes, because if you multiply the 3 to the other side, you get y equals 3x. That's similar to this letter B question right here. And then the last question is y plus 1 equals x, and it's automatically no, because if you plug in 0, 0, it's not going to work for that situation, and there's a plus 1 involved. One way to tell on 4, 5, and 6 if it definitely doesn't work is if you plug in 0 for x and 0 for y. If you plug that in and it doesn't work, the answer is automatically no, because direct variation has to go through the origin. Okay, the next one is a table showing the area that you can clean in X amount of minutes. So this is half a minute, cleans 8 square feet, excuse me. So this graph, and I've only graphed part of it, okay, but the idea is similar. Okay, this will make a nice line, and it will go through the origin. And it says write an equation that represents the line. Essentially, that's find the slope. Okay, so one way to find this for right now is just figure out what the slope is. So the slope would be up 16 over 1. I'm going to use this 1/16 because I'm not going to try to deal with fractions if I don't have to, which is what many students would also look at, okay, in order to figure out kind of the slope or the constant. And so this would be y equals 16x, which says for every minute it's 16 square feet. And then it says how much area is cleaned in 10 minutes. You just plug in 10 for x and figure out that it's 160 square feet. Again, graphing wise, remember x is first, that's left and right, y is up and down in order to find that answer. All right, this next question shows mathematically how to go about a question that says find the equation for direct variation. They're going to give you an x and y value, so y is 20 and x is 12. Remember earlier in the year when we did expressions and we said x is 5 and you plugged in 5 for x? That's the same thing here. I'm going to plug 20 in for y and 12 in for x. And then you'll have 20 equals k times 12. That's just a one-step equation. Divide by 12 on both sides, and I get 20 over 12 equals k. Now you can make that a decimal, but in general, probably a fraction is just as beneficial here. And 20 over 12 would be 10 over 6, excuse me, which becomes 5/3. And that's what k is. Now once you've gone through that, you just plug x and y in, solve for k. That's the slope, essentially, because it's from 0, 0 going up 20 over 12. That's the same idea. But that number needs to be plugged in for k. So your final answer is over here on the right side, y equals 5/3 x. That's the equation that relates x and y from a direct variation situation. Okay, this next one says you mow neighbor's lawn, you get 20 bucks every time. Since you're getting $20 every time, think of that as a unit rate. Okay, the unit rate is probably also the slope. So that constant of proportionality is 20. And so it's y equals 20x. And think about it. If you are mowing 5 lawns, it'd be 20 times 5. Now it's important to write this first equation because it says to write the equation that represents the situation. And then it says you want to buy a camera that's $189. So that's how much money you need to make, which would be your y value, because x represents how many lawns you're going to mow. And when you divide by 20, you get 9.45. But you can't mow half the lawn probably, so you got to round that up, and it's going to be 10 lawns that you have to mow in order to have enough money to purchase the camera. Anytime they tell you a unit rate, that's going to be your constant as well. Okay, your homework covers section 5.6, 1 through 18, 20 through 22, and 29 through 34. Historically, this has always been a difficult section. If you have questions, we can talk about it either during an office hour time or a class time in our next class period. What you want to focus in on is that these questions from this video, okay, are great resources to be successful on this section. Okay, so most importantly, a question like this one, plugging in x and y and solving for k, and then plugging that back in to find the equation. The graphing aspect, making sure it goes through 0, 0. And using 0, 0 on questions like 4 through 6 to see if the answer is yes or no, or the ordered pairs in 1, 2, and 3, you just set up proportions and see if they work out. Please make sure that you're looking at this section closely. You're going to have to do questions like this on your test, so you want to make sure that you understand how to solve for the constant of proportionality, like in this example on the screen, and how to write the equation for the relationship between x and y. Have a good day, everyone.